All right, so question 3 is saying a block of mass 30 kilograms is sliding on a ramp inclined at 20 degrees to the horizontal. The coefficient of kinetic friction is 0.15. Question A, draw the free body diagram. So I should draw a free body diagram showing this system here. B, calculate the value of the normal force. C, calculate the value of the frictional force. D, find the net force and the acceleration for this motion. Okay, so to answer question A, they've said we should draw a free body diagram. So if I have my incline there, they've told us that it's inclined at 20 degrees. Then I have my object here, which is sliding down. And we know to say weight axis vertically downwards, mg. Now, since this is an incline, what are we supposed to do? We're supposed to resolve our forces. We have here, the value for this angle is the same as the 20. So we have 20 degrees there, which means we are going to have our vertical component of our force here, our weight, will be mg, which is adjacent to the theta. It is going to carry a cos, mg cos theta. And this one is going to be mg sine theta, the one which is along the incline. Okay, but since this is on the surface, we're going to have our normal force there, like that. And then we also have a force that is going to be opposing this motion because they've mentioned it to say there is a force of friction, like that. So that is going to be our free body diagram for this system. Question B was saying should do calculate the normal force. So B, normal force. So how are we going to calculate the normal force? So we're going to look at the forces that are acting in the vertical component, that we've just resolved. And which forces are those? It's these guys here. So there's no acceleration in the vertical component, in the vertical axis. So we're going to say summation of forces in the y is equal to what? It is equal to mass times acceleration, but acceleration is equal to 0. That means the two forces are at equilibrium, which means these guys are equal to 0. And what forces do we have? We have Fn, which is the normal force, minus the one which is pointing towards the negative y direction, mg cos theta. These are equal to 0. So Fn, I'll take this to the other side, will be equal to mg cos theta. That means our Fn will be equal to, what is the mass of our object? They've given us to say, they give us mass anyway. Okay, so they give us to say mass was 30 kilograms. 30 multiplied by 9.81 cos 20 degrees. Okay, so that is the normal force that is acting on this object. And this will be equal to what? Fn, which is the normal force, will be equal to, when I multiply my 30 multiplied by 9.81 divided by cos 20, I'm getting a value of 276 newtons as my normal force. Okay, so that is question B, that is our normal force. Okay, question C, calculate the frictional force. So frictional force will bring down the formula for calculating friction, and also friction is equal to what? Is equal to mu, which is the coefficient of friction multiplied by the normal force, which is Fn. So friction will be equal to, they already gave us the coefficient of friction, of kinetic friction in this case, so it's 0.15 multiplied by the normal force, which we are from calculating to say it's 276. And this is going to give us a frictional force, which is equal to what? Is equal to 41.4 Newton. So that is the frictional force. Question D is saying we should calculate the net force and the acceleration. So which net force are they talking about? So the net force that they're talking about, which is going to cause this acceleration, is actually the summation of forces in this horizontal axis. The axis unity, the acceleration is taking place. And if you look at this axis, we actually have two forces. We have the frictional force, which is opposing the motion, and we have this mg sine theta, the x component of our weight, which is causing this object to actually slide down the incline due to its weight. So what are we going to do? We'll say the summation of forces in the y. So these are the forces, the x, the friction, and the mg sine theta. So let's find the value of mg sine theta first. Okay, so d mg sine theta will be equal to what? What is the mass? The mass of solid is 30 multiplied by 9.81 multiplied by sine 20 degrees. Like that. And what are we going to get if we multiply those guys? We're actually going to get 100.5 Newton. 0.5 Newton. That is the parallel component of our weight. So if that is the force that we have, how are we going to calculate the net force? The net force will actually be equal to the summation of these two forces. How much force is causing the object to slide down? So that is actually going to be the difference between these two forces that we've been given. We've been given this same force and the frictional force. So the difference between these two will give us the net force that is causing acceleration down the incline. So F net will be equal to 100, since this is the positive force that is causing movement down the incline or along the incline, minus 41.4, which is the value of the frictional force. And this is going to give us an F net, which is equal to what? Which is equal to 59.1 Newton. So this is actually the force that is causing acceleration down the incline. This is the net force that is causing acceleration down the incline. Now we're supposed to find the acceleration, and to do that, we can now bring in Newton's second law. Say summation of forces, which is F net in this case, will be equal to mass multiplied by acceleration. And we've already created our F net, that's 59.1 Newton. So 59.1 newtons will be equal to mass, which is 30, multiplied by acceleration. So our acceleration will be equal to 59.1 divided by 30. So our acceleration will be equal to 1.97 meters per second squared. So that is the acceleration. Remember to analyze and draw a proper free body diagram, because the free body diagram that you draw actually gives you a picture on how you're supposed to calculate everything that comes after this. So if you draw a wrong free body diagram, everything might turn out to be sour actually. So thank you for your time. Thank you for watching. You can help me by liking my video, subscribing to the channel, and sharing the video with your friends. Thank you very much.